So much about the general setup. So now the next thing we're going to do is talk about how to get GHC source code and start to build it. And Simon's going to do that. And because of all this embarrassing delay, we're going to show you a live demo of getting and building, but it may have to be sort of canned or described.
I shall talk about getting the sources first of all. Not just your customer. So there are two main ways that you can get the source code for GHC. The easiest way is that you can grab a source distribution, which is a file of this called GHC 6.6 source tab. And we from time to time build these, put them on the website, and you can download them. So you can either get these for a released version of GHC, or you can get them for these snapshots that Simon was talking about just earlier. And in 6.6, we've divided the source distribution into two now. There's the main source table contains just the minimal stuff that you need to build and bootstrap GHC. And there's also this extra libs table, which contains a bunch of libraries that we have traditionally shipped with GHC but aren't necessary for bootstrapping it. So we're now providing those separately, and the idea is that once you've built GHC, you should be able to upgrade those independently of GHC itself.
Do you want us to post that later?
Okay. And the hardcore way to get your GHC sources is to use Darks. Darks is the revision control system, in case you haven't heard of it. And we keep our GHC sources in a number of Darks repositories. This is a common source of confusion. There's not just one. If you grab the GHC sources, you haven't got enough to build GHC. So what you have to do is to get the main GHC repository, and you can either use this one here or the one that Paul has set up for us locally. A very good idea to say -- partial when you get GHC, because it contains 10 years of development. It takes a while to get all that over the network. So once you've got the main GHC repository, you then CD into it and run this script called darks.org, which is a small script, and it just invokes darks to get a bunch more repositories and places them all inside your source tree, ready to go. And since we changed the source tree to split it into this source and extra libs sections, you now have to say darks.org -- extra to get the extra libs as well. By default, you just get the core labels.
What happens if you don't do, say, -- extra?
You just get the core labels.
So what goes wrong there?
Nothing. You can still build GHC, but it won't have OpenGL and a bunch of other stuff.
Oh, good. OpenGL takes a long time to build.
But if you do the extra, you also get the core along with it. You can just do the extra initially.
Yeah, you can just do extra initial. Now you get everything. But it'll take a lot longer to build. So you don't have to do anything extra to build the extra stuff. It gets built automatically. It's part of the build. Sorry? Yeah, so once you've got the whole tree, you can say darks all pull, -a if you like to get everything, to update the whole tree. Okay, there are two more repositories that are interesting. The test suite here contains our tests, about 2,000 of them, and the test framework for running it. That's optional, of course. You don't have to get that, but if you want to test GHC, it's a good way to do that. And the NoFib suite is our benchmarking suite. It contains a lot of fairly old programs now, but we still use it all the time for benchmarking. Okay, and just underneath here is a list of all the repositories, and it tells you which ones belong to the core set and which ones belong to the extra libs set.
Hey, Simon, how complete is the test suite? Is it consider it minimal?
I think it's pretty good.
Yeah.
Yeah,
as new features go in, and that's what things like that.
Yeah. I mean, we had a test for every bug that we fixed on the whole.
to be fair, it's more like lazy evaluation. So as we tend to add tests for bugs, but we're not very good at adding sort of systematic collection of tests for new features. But I would say, well, add that. But, so adding tests is actually something that is a sort of low entry cost thing that is actually really useful for people to do. Just adding more tests to test the feature that you're interested in.
Get Andy to make some more stickers for you.
Good. You get special build to start that test.
So where the test suite is really lacking is testing libraries. It's pretty good at testing all the GHC features and version of testing the type checker. Bits like that. We have very few tests for actual library code. So that's a good way.
If we want to get all these auxiliary things, do they have to be put in any particular place in the file system?
Right, yeah, I'll talk about the source tree in a minute. Darkstore will put them in the right place for you. Okay, and that's saying how you can use Darkstore to just pull new changes.
And if you want to use the local repo for Darkstore, you have to edit that script.
Actually, I think if you get GHC from the right place, Darkstore will get everything else from the right place for you. So all you have to do is...
It uses, well, it'll use the, I just played around with it, it'll use the darks.haskell.org.
Oh, will it?
Yeah. But you can change it.
You're strongly encouraged to use the one there because you're going through a T1 line into the Gala building to get the repo right now. So that's what we're fortunately trying to say.
So we've started to write a roadmap to the source code in the wiki. It's not complete, but it's very good at the top level.
But at this stage, everybody should have enough, and they should be able to do a docs yet.
Yeah, yeah. So is anybody having trouble? Nobody doing it at all?
We're all just here for the show.
So it would be quite a good idea if you don't have to build JC to try to get a copy of the sources, because we'll look at some of the sources when we're looking at details of the file.
Yeah.
So just being able to browse the source would be helpful.
Very good.
You can do that through a browser.
So at the top level of your source tree, there is a bunch of stuff that's to do with automatically configuring the build. And then there's a makefile, and the MK directory contains the build system itself. It's not a GNU makefile or magic. I'll talk about it shortly. This is all in alphabetical order, so it's not in any particularly useful order. But the compat directory contains code that we use to smooth over the differences between various GHC versions when we're building GHC itself. So the idea is to try and bring up your installed GHC to the level of what we need to bootstrap GHC. And in particular, we build a bang up-to-date copy of Cabal inside there and put it in the library that we can then link into GHC when it goes. So the compiler, of course, contains a Haskell source for the compiler. Driver is historically named. It used to contain a Perl script, which was what you invoked when you typed GHC. And it behind the scenes would invoke a Haskell program called HSC. So that's no longer the case. You now invoke the Haskell program directly. But under Driver, there's still a couple of scripts. The thing that we call the evil mangler, and something that's perhaps even worse, called the splitter. So under libraries, you'll have all those packages that we checked out separately using Darkstore, and also a bit of build system stuff. Under includes a bunch of header files for the runtime system, and header files that are used when you're compiling via C. There's some documentation, some quick check tests, which should probably go in the test suite. RTS is the runtime system. Under utils, there are various programs, some of which we install with GHC, like HTTP profile. Some of them are used during the build. We've got programs that generate various bits of the runtime system, for example, and they live under utils. We've got test suite and Notebook, which are the optional repositories. Okay, and a bunch of things to do with distributing and getting sources and so on. Okay, so I'm going to do a live build, at least I'm going to try, to demonstrate that it at least works on somebody's machine.
Hackathon shell.
Okay, so I've just got the main GHC repository. I'm going to.
Of course, it's faster to change the the one line and carry on, that's the problem.
There we go, that's what. Yeah, that's great.
That was really quick. Okay, so the first thing you do to build is you say auto reconf. And what that does is it turns these files called configure.ac into configure scripts that you can run directly.
So what's the difference between auto-conf and auto-reconf?
Auto reconf works recursively, so there are several configure scripts in the tree.
So re as in recursion.
Yeah, yeah. And it also generates some other files. So auto reconf is necessary, auto conf doesn't work.
Auto reconf is running as well as.
Yeah.
Did everyone talk loudly when you sort of ask comments and look like just so we can hear about?
Complains that this map is bigger than
So if I could say a little bit about this page in the building guide, which is called Quick Start for Developers, and it's supposed to be a quick sort of guided tour through how to set up a build tree the first time and the kind of things that you commonly want to tweak without going into all the detail about the things you can tweak. So there is one file that you need to know about to configure the build. And it's the file muck/build.muck. It doesn't actually exist in a source tree to start with, so you have to create it. If you don't create it, then you get a default build. The default build is set up to build everything optimized, build everything as much as possible, build profile libraries, and basically it takes a long time to build the whole thing out. So if you're developing GHC, what you want to do is set up the source tree so that it builds things unoptimized, so that it uses various options that tune the build for speed rather than optimization. So here we've got an example build.muck.
Yeah, I tried that exact example. I just followed it directly on the Mac. PowerPC gave me undefined symbol variants. I don't know why that is, but it built perfectly.
Okay, I'll
With default, but it did that power.
Could be really.
Yeah, regular symbols that were undefined.
Which version of GCC are you using?
GCC? Yeah.
So I'll explain each of these options in turn. This variable called src_hc_ops is the name for the set of options that are sent to all Haskell compilations during the build. src stands for source, so it's the source tree HC Haskell compiler options. And by default, as I said, it's set to do full optimization. So what we're going to do
Is there a comment character for build.muck?
hash.
You need to go through that.
Control C and then
Back to your
The tree I have is from
try
Oh, so big.
which one's more?
Units of class, it could be a possibility.
hey,
Not that I have no confidence you must do.
What do I have?
so what I've done here is I've set source HC ops to bump the heap zones by default. That just makes the build feel a little bit nicer. Optimization, but I've turned on native code generator, which is a little bit slower than via C on some platforms, but it goes much quicker. So it's a good idea to do that. This GXE timing thing just outputs some stats after each half of the compilation, so you can see whether garbage collection is taking too long, or basically lets you keep an eye on what's going on. Now, GXE stage 1 HC ops is the setting for the stage 1 Haskell compiler. I haven't said anything about stages or children. In a GXE build, we generally build GXE in 2 stages. The first time we build GXE using whatever GXE you've got installed, and that's called the stage 1 compiler. And that compiler is then used to build the libraries. Having built the libraries, we can go back and build GXE again using that compiler that was built in stage 1. And the second compiler we built is called stage 2. So this setting here sets options for building stage 1. And here I've set -O0, which means turn off all optimization. And -D debug turns on debugging code in the compiler itself, so it turns on assertions and extra checks in GXE.
Source HC also apply to all stages.
Right.
And
So
these
source
extra
HC
flags are sort of concatenated on the end. Is this right?
That's right. GXE stage 1 HC ops will override anything in source HC ops.
It's possible that enabling debug calls some sort of undefined instance of show for prereqs.
Don't know about that. What platform?
PowerC.
It's possibly something wrong with the debug code in the PowerC native code generator. I'll have to look at that. Okay, so we've got some options for building libraries. So when we're building libraries, we go back to the optimization again, and we turn on this extra generics. That's just something that we usually turn on when we're building libraries. It generates some extra code for generics. If you don't do it, then you can't use any generics against the libraries that we built.
Do you still want keep HC files under libhc ops? There used to be a flag called keep HC files.
Okay,
Do
so
you still want that?
Want to repeat the question, Sam?
the question was, do you still need to flag keep HC files in GXE libhc ops? And the answer is only if you want to generate HC files, basically. So if you want to be if you want to use this build in order to bootstrap another build on another platform, then you need HC files. If you're debugging the C code generator PowerShell, it's not necessarily otherwise. So the fourth setting we've got here is GXE lib ways. Now, when we build libraries, we often build them in several different ways. Where a way governs how the library is compiled and what variant of the runtime system is going to be using. So the most common ways are the normal change listed, and the profile way, which changes the layout of closures and changes a bunch of other aspects of the execution model. So that's why you have to build the whole model of libraries again in a different way. But when we're doing a development build, unless you're going to be experimenting with profiling, there's no reason to build all the profiling libraries as well. So we just set GXE lib ways to empty, and that causes it to build the normal way over. Okay, the last setting, quite important for speed again. Split objects is a technique that we use for optimizing binary sizes. And what it does is when you build a single library module, it splits it into lots of little object code, object files that are then all bundled together in the final library. And the idea is that when you link against the library, it only pulls in the bits you need. So rather than pulling in the entire module, you pull in just parts of the module that you've used. But it takes a long time to do that. And compile time, obviously, so turning it up speeds up the build quite a bit.
Simon, is it known why it takes a long time? Would that be a good thing to work on this weekend?
No, I think it's just because you have to split up the object files. So you have to split up the assembly file, invoke the assembler separately on each assembly file, and then combine them all again. So there's not much you can do about that. So I set my build.mux file up. The next thing you do is configure.
I'll often find that there's a useful template file, build.mux.in, isn't there?
No, build.mux.sample.
.sample, that's the one.
Yeah.
Right.
You can
So it's in the same thing. I often, and as its name implies, it's a template for a more sophisticated version.
So you can copy that onto build.mux if you want to.
Right. That's why I said that. I often copy build.mux.sample to build.mux and then look at that and edit that.
Yeah. So those 5 things that I set there are the most important things for splitting up the build. So we'll run configure.
If you're going to Mac, there's another line you use rather than configure.
There is?
Yeah, it's on the wiki about how to build on Mac. It's the rebuttal issue.
Okay.
Whereabouts on the wiki?
It's probably not where you're looking. It's off the platform page, I think. So it's in the building section, the section of platforms.
I just tried to run auto-recall, and I have all the prerequisites that was on the wiki page. But it's saying something to the effect that I need automate. Is that
Yes, you need to install automake as well.
Actually, mine says I need configure.act, which I have. And we have a similar problem.
Can somebody make a note that we need to update the wiki and say you need automake as well?
which initially?
Sorry, which automake? I think 259
Let me see if I can get a file.
So if you're lucky enough to have got to this stage, then you can just say, give it to
Okay, so tell you what, so at this stage, so at this point, if you've got through the auto recon configure stuff and type make and everything's happening like this, then you're happy, right? And if you haven't or you've got stuck, then let's sort of do a bit of parallel processing now. Stick your hand up if you're having trouble, and sort of, along with the sign, say what kind of architecture you're on. People who've done this before, or who know what they're talking about, can come and help you, right? There's quite a lot of them in this room. Let's just do that for the next 15 minutes or something. Just,